Yo, what's up guys? So today we'll be talking about exponents and radicals and how they aren't so different after all. So let's just start simple. So exponents, okay? What do exponents actually mean? Well, if we had something like 3 to the 5th, you guys know that it's equal to whatever 3 times 3 times 3 times 3 times 3 is equal to, right? It's just 3, or whatever number the base is, times itself 5 times, right? And now let's look at radicals. In this case, we'll look at the square root. So just for clarification, I'm going to do the square root of 16. Well, what is this asking? Well, it's basically asking what number to the second is equal to 16. Okay? So it's almost the reverse of an exponent. And as we all know, the answer is 4, right? Because 4 times 4 is 16. So I want to tell you another way that you can write radicals. So if we were to have the square root of 9, we can rewrite this as 9 to the power of 1/2. And you may be wondering, okay, why 1/2? So there's a few important things about why it's written 1/2. Well, the 1 is in the numerator because it's actually 9 to the power of 1, or the square root of 9 to the power of 1. And a 2 is in the denominator because it's the second root, right? If it were, I don't know, let's say the cube root of 27, if you guys could have guessed, that's 27 to the power of 1/3. Now, let's get a little more complex, okay? How about we do the fourth root of 81 to the power of 2. So there's a few things we can do here. One, we could evaluate this like normal, right? So 81 to the power of 2 and then find the fourth root of that. Or we can start writing it like the exponents that we've seen. Okay, well, we have 81, it's to the power of 2 and to the fourth root, so we know it's going to be 2/4. But 2/4 is not simplified, right? We can write this as 81 to the power of 1/2. And what does it mean when something's to the power of 1/2? It's equal to the square root. So we know that the fourth root of 81 squared is equal to 9. Now let's talk about negative exponents just quickly. So what does it mean when you have something to a negative exponent? So let's say we have 3 to the power of -2. When you have something to a negative exponent, it actually means that instead of it being in the numerator like this, it puts it into the denominator. So 3 to the power of -2 is equal to 1 divided by 3 to the power of 2, which is equal to 1/9. Okay? And you know, this works the same for, we could do 4 to the power of -3, right? It's equal to 1 divided by 4 to the power of 3, and so that's equal to 1 divided by 64. Okay? And you're like, okay, well, what happens if you have a negative exponent in the denominator? Okay, so well, it's going to be 1 divided by, I don't know, 2 to the power of -3, right? You just flip it to the numerator. So when it's a negative number, you just flip it from numerator to denominator or denominator to numerator. So this is going to be equal to 2 to the power of 3, which is equal to 8. Okay? Now let's cover some exponential properties. There's 3 main exponential properties. Let's talk about the product property. Okay? So let's say that we have something like x to the power of m, times x to the power of n. That's going to be equal to x to the power of m plus n. So when you're multiplying two exponents with the same base, you add their exponents, okay? So let's just do a quick example. Let's do 3 to the power of 2 times 3 to the power of 3. Well, we know that's going to be equal to 3 to the power of 5, and 3 to the power of 5 is 243. So let's prove that this works. Okay, well, what's 3 to the power of 2? That's 9. And what's 3 to the power of 3? That's 27. So if you were to get out your calculators, you'll find that 9 times 27 is 243. So look, so that proves that when you multiply two exponents at the same base, you add their exponents. Now let's talk about the quotient property. So if we were to have x to the power of m, that was a bad m, divided by x to the power of n is going to be equal to x to the power of m minus n. Okay, well let's test this out. Let's say we have 2 to the power of 4 divided by 2 to the power of 2. That's going to be equal to 2 to the power of 4 minus 2, which is 2, and that's equal to 4. Okay, well let's try to prove this. 2 to the power of 4 is 16, right? We're dividing that by 2 to the power of 2, which is 4, okay? And that's going to be equal to 4. So look, we just proved that. Prove that one again. Now for the final one, the power property. So this says that whenever you have an exponent to the power of another exponent, you just multiply them. So x to the power of m to the power of n is just equal to x to the power of m times n. So let's test this out again. Okay, let's do a simple one. 2 to the power of 3 to the power of 2, and that's equal to 2 to the power of 3 times 2, which is 6, and that's equal to 64. Okay, so let's try to prove this. Well, 2 to the power of 3 is 8 to the power of 2, and that's equal to 64. So look at that. So that's kind of it. That's basically all you need to know. That's the basics. But you kind of just have to put that into practice. Hey guys, thanks for watching. So today we just covered exponents and radicals and their properties, kind of a shorter lesson. So, I hope you guys learned something. Check out Khan Academy, and peace.